Hello, everyone, and welcome to the Weekly Space Hangout for Wednesday, February 14th, 2018. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about Lisa Pathfinder and how it's doing awesome. The 4 VLT telescopes merging together to form the Voltron Espresso Instrument, and what's happening with the new budget for NASA. Don't panic. It's going to be okay. Joining me this week, Morgan Renberg. Morgan.
Welcome back, Fraser.
Congratulations on running the show last week. You did
I survived one episode, and I don't know how you do it week after week after week, year after year after year.
Well,
So,
that's
consummate professional.
I think you just explained it, right? It's a practice thing. So that's all I got to say. I just do it a bunch of times. You did a great job. You guys did a fantastic job. I really felt like it was in good hands with you. And I mean, just to hear Pamela and Nicole and everybody there involved, it was great. So good job, everybody. And I listened to the episode on the airplane back from Iceland, which was awesome.
Were we an effective sleep inducer?
No, it didn't put me to sleep at all. It was great. Actually,
Sorry about that.
The funny thing was I was in Iceland and it was like 2 a.m. and I was totally jet lagged, and I woke up and I couldn't get back to sleep. And then I was like, I wonder. And I checked the time because my phone was like, oh, it's time to do the Weekly Space Hangout. I'm like, oh. And so I went and checked, and I just caught like the last minute or two of it. And so I said hi in the chat, which was hilarious. So, all right, you're the regular member. We've got a special guest joining us, Joe.
The irregular member. Greetings.
So you're gonna be half guest, half correspondent. So this is gonna be a lot of fun. Joe, why don't you let people know who you are and what you do?
I am obviously Joe Pappalardo. I am a contributing editor at Popular Mechanics. I was on the staff for 7.5 years or so. Still affiliated with them because they're amazing. Love to work there. And most recently published Spaceport Earth book about the growth of spaceports in the United States, commercial space, and tried to get to as many of the working spaceports as possible. Of course, they kept sort of springing up with more FAA designations as I was writing the thing, and Elon was crashing rockets. So we delayed it a little bit to see how things shook out, especially at the Cape. And it came out late last year, and it covers from 2011 to early 2018, and a lot of the times of sort of pivotal change and reinvention that's sort of going on in the launch markets, and that's what I've been dedicating myself to for a while now. So
I mean, when we all think about the state of spaceports, there's there's the Kennedy Space Center, of course, but what are the others that you were able to find?
Although the FAA designations are one thing to chase around. So you've got the vertical launch areas, which are Vandenberg, which does government and also SpaceX launches from there in ULA. You've got Wallops Island in Virginia, which I caught a moonshot, the Laddie launch from there, which is very, very cool. And then subsequently, I wasn't there for the immolation of that launch pad and the subsequent rebuilding of it.
Right.
That had happened also. And then the Congress came and sort of raided the NASA budget to rebuild it, which is sort of captured in the book. And the other sorts of, so those are the big vertical ones. And
that
there's
was the Antares explosion that went off a couple of years ago. Yeah.
Oh, it went off all right. Yeah.
Yeah, one of our correspondents for Universe Today was there and sort of described, actually on the show, what it was like to go through, having your kind of face warmed by this rocket going off. Yeah, it sounds like it was quite an adventure to be nearby and a lot of work to clean up.
It seemed, you think that, it's just a slab of concrete where you launch rockets, but they're very complicated bits of engineering. And when you've been to a particular pad or any pad and you see something like that happen, you start thinking, oh, that's going to take a while to rebuild. And you think about launch schedules, and it hits you a little bit more viscerally when you know what's just been blown up.
I mean, even the SpaceX one, and Morgan, you were there too. We got a chance to see. We were at the Kennedy Space Center for the OSIRIS-REx mission, and they took us past the SpaceX launch gantry after it had had its explosion, and it was this kind of melted sculpture of metal.
Yeah, it is a good reason that Musk was hoping that the Falcon Heavy would get high enough off the launch pad that if it blew up, it wouldn't level the thing, because it looked like a bomb had hit it, because that's basically exactly what had happened.
Yeah.
And that's where commercial crew's going to go off too. So he better have cleared that pad. That would have been more than just a small losing of face. That would have been a catastrophe.
So what other ports are out there?
So one of the cool things, so there's the experimental spaceports that have launch licenses. So that's Elon Musk and Jeff Bezos out in Texas launching their spacecraft, developing, the landers that we see out into Cape now. Elon had, his landers hopping around in Texas, and Bezos is doing the same thing at these sort of very, Bezos is a lot more secretive than Musk was, but they're both right there in Texas in these small towns. So you have that sort of frontier flavor. And then at the end, the other one that came on later in the book process was airports that want to be spaceports. And there's I just naturally thought that was my dog. I was looking around at the
Yeah, no, it's mine.
So a lot of spaceports, and there are consultants wandering around the country talking to municipal airports that have reasonable runways and a little bit of empty space to put the propellants and do the other infrastructure. And they want air launch, they want point-to-point air travel, they want industrial parks that have that luster of spaceflight to them, so that they can attract clients. And even if nothing launches from them, they still want that. And my biggest stand-in for that, although there were several, was Waco, Texas, there's a small tech school down here that it's a reasonably sized tech school, has a great airport, great aviation program, and they're working on getting their spaceport license. So I was able to sort of embed in that process and see some of the hurdles that they're jumping through, and learned a lot about municipal airports in the meantime. So there's a lot of different categories. It wasn't just the vertical launch areas that caught my interest, although certainly the reinvention of what's going on there was a big part of it, no doubt. But it wasn't the only thing going on. It's really coast to coast in places you might not reasonably expect a spaceport.
Well, when you think about things like, say, a Pegasus launch, right, which is launched from an aircraft, which is launched from a runway, is that a spaceport? When you think about what's going to happen with the Mojave spaceport, that's going to be helping launch the Spaceship Two and things like that. So it's interesting to sort of see more and more people. So did you get that sense? And I think, as you said, that the book took a little longer to come together. Is it as if like spaceports were cropping up faster than you could incorporate them into the book?
It was whack-a-mole and I lost. I mean, that was the way that I sort of viewed it. I had to content myself with, okay, this one, I'm going a little bit deeper to explain that the process that's going on in Georgia and in different parts of Florida and other places. And what really happened in the late stage is that it went global. And Australia has a space agency and spaceport dreams, and in Europe now, and it's starting to really, you're starting to take a look around, and it's going more and more. I'd love to have gone to Japan or India. I mean, all these places are really, it's a global phenomenon now, and it's real, to me, it's really exciting for the future. Not all of them are going to have space launches. Not all of them are going to be successful, but not all of them will even get their designations, not to mention use it for any real way. But it's still exciting to see, because there's enough interest and enthusiasm and launch companies that they think that there'll be markets for that opening up. So it's a really positive sign.
We've got one here in Canada, in Nova Scotia. There's one now in New Zealand, of course, with the Electron rocket. The Chinese are just launching them into suburbs.
dropping
boosters into suburbs. There is the Sea Launch system, which might be seeing a new lease on life.
Maybe so, yeah.
Yeah, so it does feel like these things are popping up kind of everywhere. What's going on? Is there some kind of meta sort of financial story that's going on that sort of explains this?
There's a couple of ways you can cut it, and depending on your level of cynicism, you can apply
very high.
Then we can go straight to the politics. In Texas especially, but Florida, other places, they see this as innovation jobs. They see this as a way to spur the economy, something that a state government can do to actually influence the economy, actually create jobs and take responsibility for that. So, or take credit for it rather. So a place like Texas has several different sort of slush funds. And if you declare yourself a spaceport, these funding streams come to your airport. And that airport becomes an industrial park, and there's the possibility of space flight happens. In Waco, for example, that airport actually did some of the work on Pegasus and is doing work on air launch. So the facilities there have already done sort of spaceflight stuff. They go somewhere else to test it. Why not test it there? Why not bring payloads back? So there's an economic incentive there too. The rosy view is people like space, that people are reinvigorated, that the idea of making money in commercializing space is not a pipe dream. No one laughs at it. Well, not many people, and depending where, they laugh harder than others maybe, but it's a very real impulse to try and support that. And more politicians are doing it, more airports are interested in it, more incentives to do it, and more customers. I mean, it's not like Virgin is the only game in town. You have to build a spaceport for Virgin Galactic and their rich customers, right? You know, that's not the model. That should never have been the model, and that's not the way that it's spreading. So a more rational way of approaching spaceflight has come upon us, and the spaceports are spreading accordingly.
Arjone in the chat asks, what does the local economy get in return for being a spaceport?
The local economy, well, I mean, if the airport gets better tenants, then there are jobs and tax base. So even having in McGregor, Texas, down the road from Waco, you roll through that town and, you see it everywhere. You see it on Fixer Upper on the TV show. You see SpaceX employees moving into houses down there. I mean, those are jobs, and hopefully they stay in these airports especially, but in, vertical launch spaceports as well. You don't want to leave. You set up your infrastructure, you set up the way of doing things, everything's set. You want to stay, and the jobs want to stay there too, and the politicians and the local economic development people want those jobs to stay there as well. So it's all very rational. It's not it's a roll of the dice, but it's one that makes sense. And again, if you don't launch from there, it doesn't mean you don't get something from the designation. So just spend a couple $100,000 on a consultant. What's the big deal? You can make it back.
Right, but it's strange to me that you've got all of these people who are setting up spaceport designations, but no necessarily concrete plans to actually have a vehicle that's going to take off from their facility, right?
Well, they have to have a plan for a vehicle to take off from the facility. You can't just say, oh, I'm a spaceport, but if I can get a vertical launch, I'm going to do it. Or if I can get a horizontal, you have to know what the hell you're doing to set up your fuel, to set up the propellants, and the oxygen, all that kind of safety. And you have to say it's going to be an air launch of this size, of this, and you can calibrate it later. I mean, it goes up and renew and tinker with it, but you have to be that far along. So it's not that sort of, willy-nilly, but it is a little bit shooting from the hip, and it is, if you build it, they'll come. It's a gamble, but you can still gain from doing it, and I think that's why a lot of people are pursuing that.
Well, Larry Beckham makes a great point in the chat. Who wants to hear a BFR land or launch daily or more? Like, on the one hand, you can kind of, like maybe 3 days in a row, right? You're going to have 3 days in a row. Like, rockets are loud. Like
people
living.
already hate living next to like 747s taking off, and
but like that
100 times louder than that.
Yeah, 100 times. Like, whatever. The space shuttle was the loudest noise ever produced by human beings or something. Like, it's a ridiculously loud vehicle. Yeah, it's going to be exciting to see 3 of them go off, but then every day as these PFRs are coming in, causing all this noise. You can imagine, like, on the one hand, you're like, oh, this is super exciting. I can't wait to have an airport near my house and I can watch airplanes land. And then after a while, you're like, I don't want to be anywhere near these airports.
It's the blessing and the curse. I mean, right now, the NIMBY part of spaceport politics is more about the financing and why should we pay a billionaire sky on any kind of money to build. It's the same thing with the sports stadium, right? I mean, it's that same sort of debate. And Spaceport America didn't do those debates any favors because of the way that was sort of put together and the sluggishness of getting it up and running. So if you divorce yourself from that model a little bit, it's not as big of a stretch. And if you're talking about air launch, they're flying away and launching somewhere else. So it really is just the planes coming up and down. and they're going somewhere else. And that, that kind of plays into that part as well. The vertical launch, there's no getting around it. Those things are loud.
Is there enough capacity? Because, one of the kind of interesting things about like the NASA InSight launch is that it's going to be going out of Vandenberg. And one of the reasons I understand is the Atlas queue is full on the East Coast. So on the one hand, you've got this explosion of facilities, but you don't necessarily have the and that's a terrible term for me to use, a cropping up of new facilities, and yet maybe not the right kinds of facilities for what you're going to need to fulfill. I mean, if SpaceX does crank up the noise, increase, they're going to do whatever, 30 launches this year, maybe they're going to do more. Blue Origin gets in and starts launching their rockets. Plus we've got SLS. Plus we've got all these Atlas, and then you've got the Vulcan. Is there enough of the right kinds of facilities to actually fulfill the needs of the space industry?
It's a $1 million question. It's a more than $1 million question.
$1 trillion, I believe.
They don't know. They don't know. I mean, if you look at Brownsville and Elon Musk building his own spaceport there, and the crowding that happens at Cape Canaveral, it makes a lot of sense. We need more vertical launch areas. There's very defined set customers coming up that you can say, I need this, I need that, I need that, and it's all vertical launch. We don't have that with what they call it responsive space, where, all right, our satellite just got disabled or knocked out. And this is on the defense side a lot more so. We need to do something, get something up there, snap really quickly. Let's do an air launch. Or, there are other, none of them are market ready.
Yeah.
None of them have a good client base. And that's the gamble. That's the leap of faith. And again, they say, well, I can get a spaceport designation, get a little ink, get a little extra state money pouring in. All of a sudden, the municipal airport perimeter security just got, increased. That's going to help you sell to a defense contractor. It has nothing to do with spaceflight at all. But
right.
You're just there.
Yeah, and that's my point. Is that you're not going to have the facility to store the rockets, to stack them, to roll them out, to put them vertical, to launch them. I mean, that is, what it's going to take to be able to launch even just Falcon 9s.
Not air launch, though. Air launch is a lot leaner, a lot smaller.
For sure. But I'm just saying, like,
small fat trim and all that stuff. But with verticals, you're right. You can't do it small.
Right.
You got to have elbow room. That's why that Brownsville site, if you go down there, you're in the middle of nothing. There's nothing down there.
Yeah.
And that's the way he wants it, except for that creepy little Boca Chica village that's there. There's not a lot else to drop boosters on. Go ahead. So the vertical launch spaceports are in areas that are empty, and that helps keep the NIMBY down quite a bit. That they're not in my backyard impulse, but it's harder on the infrastructure because not as many people are around to pay it. So on the vertical launch areas, that's sort of the trade-off. But at least there's a known market for that stuff. There isn't so much for air and the other ones. Not so
then,
much.
do you see that being part of the almost like the drive towards some of these air launches, that you can have a more flexible, you can reutilize an existing sort of commercial airport or something, with, as you say, some kind of security upgrades. It's relatively straightforward to put one of these, say, a Pegasus rocket, and take off from any well-equipped airport, that they're going to be able to fill that gap while the big vertical launch facilities catch up with the demand and the increased. Because, I mean, this is what I see, right, is that you see the price of the rockets coming down by a factor of 5 or whatever, like whatever it is, that a Falcon 9 now costs $60 million when before you had to pay $200-300 million for an Atlas or a Delta. You've got a lot more people who are now suddenly saying, hey, I could launch a rocket. I could put my, that satellite we could never afford before. Now we can. What if
launching? Here's the word that they all love. Space plane. If you're launching a space plane, it can launch on a rocket, it can do its mission, and it can come down in any spaceport, anywhere that's equipped to do a space plane landing, and that's part of you can get that designation, right? So,
but who's got a space plane?
Dream Chaser, Sierra Nevada has got one. Virgin.
And but there's one that was just shut down. Oh, what was the one?
Oh, the one in Odessa, Midland, Odessa.
Yeah.
That was taking off from how quickly we forget them when they get canceled.
Exactly, right?
I bet the Lynx.
Yeah,
the Lynx. Yeah. And you know what happened in Midland, Odessa? They got the spaceport designation. They got the Lynx interest, and They got a facility for spacesuit testing and space component testing right there on the airport grounds before Lynx got canceled, and that facility's not going anywhere. So they benefited from that, and the Lynx is DOA. Who cares? They don't care. They care, but they still have this other, it still worked from their perspective that they got this other tenant to come in. It's all about getting tenants to your airport. So if your tenant is a big defense contractor or a university, and they want to launch on a space plane out of Cape Canaveral, look at the shuttle, backup plans. Those things can land anywhere that's ready for it. So if you're L3 or Boeing or whatever the hell you want, Raytheon, and you've got a facility there and you can set up a place to process your experiments, or you just set up you're an independent contractor who says, I'm going to set up my facility I'll host your experiments when you come and work on them, so you get them right off the space plane. Not so bad. And then all of a sudden in Dubai, you've got point-to-point travel, if you want. So all of a sudden you're equipped for that too. And you're planting a flag when it's cheap in this industry, so you're ready to capitalize later. And in that regard, it's such a terrible idea. And, compared to other ideas, it's really not that bad for economic development. I mean, on the scale of scam to not scam, and maybe this is my bias, but I'd rather have them spending money on this than some of the other worst crap that they throw money at.
Well, Joe, we could go on about this all day, and in fact, the interview that I have. Well, hold on. So the interview that I had with Chris later on sort of covers similar ground, but more specifically, sort of how the SpaceX is going to play out. But I'm fascinated. I mean, it's so funny. It's kind of ironic, right? That suddenly now we're all incredibly excited. There's so much potential. Everyone is rushing into this, and it just feels like space exploration Christmas. So the fact that we're even concerned about how everyone's going to find places to launch all their rockets so that they can send humans to deep space and mine asteroids is a great problem to have. All right, so hold up the book one more time. Tell people where they can find it.
Amazon, Barnes and Noble, pretty much all over the place.
Spaceport Earth.
Spaceport Earth, the reinvention of spaceflight. And
awesome.
There's this little guy here. Which is, I don't know if that was supposed to be me or not, but I mean, I try to pretend that it is. But I didn't go into space for this book.
Not yet.
I was French Guiana.
Well, Blue Origin will give you a shot pretty soon. But and then where can people follow you out there on the internet?
Oh, at Pappalardo Joe on Twitter. That's where I do the touting those stuff I'm writing for Pauper Mechanics and book related stuff, and just sort of keeping up with all the really hardworking daily space journalists who without them, I should have dedicated the book to them. No offense to my wife on Valentine's Day. Sorry, honey. I should have dedicated it to them, because those guys, and at the Heavy launch, Dragon Heavy, I was reminded those guys are so badass. They do it every day. Magazine people really owe a big, and book writers especially, owe a big debt to the ones on the front line. So I figured I'd just say that now. All
right, you're going to stick around. We're going to talk about NASA budget, and you've got some thoughts on that as well, and a couple of other topics. Morgan, you want to set this one up?
Sure. So earlier this week, the Trump administration released the president's budget request for fiscal year 2019. And if approved or enacted, this budget would take effect at the start of the fiscal year on October 1st. And I say if enacted with like the largest possible air quotes, so being crushed to death under these air quotes, because president's budget requests literally never get enacted. You could probably go back to the Kennedy administration or something to find a president's budget request that actually sailed through Congress and was adopted. But they're still useful things to look at because they sort of tip the president's hand to what their priorities are. So we can look at the numbers for NASA and see sort of where the Trump administration and NASA, because that's an executive agency, is thinking about going in the years to come. So on the top line, the NASA budget looks pretty good. They were requested $19.9 billion, which is a bit of an increase over NASA's budget from last year. And the big winner here is planetary science, which saw an increase of about $400 million up to a little over $2.2 billion. And I remember a few years ago when I was helping advocate for increasing the planetary budget. And the number we were looking for at the time, just in the last few years, was 1.5 billion. And so to see the planetary budget even being talked about at something like 2.2, 2.3 is just enormous. But that does come a little bit at the expense of other parts of science. So the budget proposes to eliminate one of the special technology development programs to develop sort of advanced future technology. And the biggest cuts come to astrophysics, which sees a 12% would see a 12% cut in their budget and would cancel plans for the successor to the James Webb Space Telescope, WFIRST. And then sort of in the middle, kind of bad news, but a lot less bad than I think most people are expecting, is the budget for Earth science, which sees a cut of just 6%. Now, that comes with plans to shutter some of the Earth-observing satellites operated by NASA on behalf of NOAA, the National Oceanic and Atmospheric Administration. But still, I think probably 2 years ago, people would have been suggesting that the Trump administration might just sort of zero out the Earth science line from the NASA budget, try to move it elsewhere and sort of fritter it away. And last year, they cut the budget only very slightly. And again, this year, we're seeing the proposal for a 6% cut. And so, all things considered, this is a pretty good number for Earth sciences, given the environment that we're in politically right now.
Right. That was very politically well spoken there, Morgan. But help everybody manage their expectations, because to hear we're going to lose WFIRST and also NASA's Office of Education, which, I mean, we kind of depend on a lot of that for a lot of the information that we try to use to try and spread the education. So tell me we're not, how, because you didn't seem completely freaked out about WFIRST getting axed. So how are you so calm and confident?
So it's not a good sign for WFIRST. That I think is fair to say, because regardless of whether or not the president's budget request is enacted, NASA works for the president. And so what the president asks for is essentially what NASA is going to be looking to do. Now, if Congress says thou shalt do WFIRST, it'll be done. But this definitely takes some wind out of the sails of WFIRST. And I guess to me, this isn't a shocking outcome in the sense that we're talking about the successor to a telescope that hasn't yet been launched, that's horribly behind schedule and over budget. It's not surprising to me that government officials might be having a bit of a sticker shock with James Webb that's carrying over into something like WFIRST.
Wait till they see how much LUVOIR is going to cost.
That doesn't mean that James Webb's never going to have a successor. And the development done for WFIRST to this point, we haven't been building anything. We're not even really designing engineering plans in the sense that schematics are being drawn up and such. And so there's plenty of opportunity for sort of a pause in the development of something like WFIRST that wouldn't be catastrophic to its ultimate or the ultimate success of a similar telescope. And then with something like the Education Office, now NASA reorganized education a couple of years ago following a directive from the Obama administration. And in the end, spending on education didn't really change. It's just sort of where that money came from. Yeah. Change. So it used to be that every little NASA mission would do their own education, right. And that was kind of brought centrally, and people like CosmoQuest were able to apply for much larger grants from the government to do NASA education. And so I haven't sort of plumbed the depths of this budget request, and there's usually very little detail in sort of how these things would actually be operationalized. But I wouldn't expect this to mean that there's not going to be NASA TV anymore or something like that. It's just sort of where the bookkeeping is done, right, might change for a lot of these efforts.
Yeah, and I think that even from NSF grants, I mean, there's always budget set aside for outreach, and so you can kind of see every one of these programs, every one of these, probably that outreach money moving back into the individual grants that are made. Because I do remember, back in the day, there was a much there was many more smaller websites put up by different groups to talk about their specific instrument. There were websites for instruments, there still probably are, and now you can kind of see that all sort of more came together, and now you can see that kind of going apart again. So
I don't want to come off as sort of too optimistic, too rosy.
You seem super optimistic about this.
If you're somebody who thinks that education is a vital component of science, and especially an important aspect of astronomy and space exploration, then obviously any move in the direction of cutting resources or moving resources in education is not a good sign. But before we sort of graduate into full-blown panic, we should wait to see what the final passed budget numbers are, because the Trump administration's budget basically cuts spending across the board for domestic programs, but we know that spending will increase for domestic programs over the next 2 years because Congress passed a law saying that just like a week ago. Right. And so the president's budget is a very empty gesture towards cutting things like this, but actually we know that on average, programs like NASA should see increases over the next 2 years because that's exactly what Congress agreed to. And so when they start filling in the gaps over the course of the rest of this year, that's when we'll start to actually see how these changes get translated into stone. And then if you start seeing some of these things persisting, that's when it's okay to start freaking out. But right now, this is just like, one guy's daydreams in the Office of Management and Budget, and who knows what that'll actually mean.
So when we see Congress marching arm in arm into voting with a bill that has all of this says, that's when we panic.
Yeah, no, that's not a good sign. But the way you get not to that point is by expressing alarm and concern now.
Right.
And so it's not at all misplaced to say, if we go down this path, bad things for science, bad things for space exploration. But we shouldn't, start leaping off our nearest spaceport gantry until we get a little farther down the process.
Now, Joe, you had perspective sort of from the military and Pentagon point of view, right?
Yeah, the space portfolio, and I agree entirely, Morgan. It's where things are going rather than the actual numbers, but it's a little more solid on the Pentagon side, especially as the funding there is pardon the pun, exploding. But space is a huge priority. And we had the news today that hardened GPS satellites, major program coming out. We've got I've been poking around their use of nuclear hardened communication satellites in GEO, another area where they're doing more and more money, more and more research. So secure communications, secure satellite comm is a big deal. The money going into space on the Pentagon side is not going anywhere. It's only going to increase. It's every, from the Secretariat on down, they are making a concerted effort. So the players in space increasingly are going to be military, and the militarization of space is a huge part of that. And that all plays into the modernization of the ICBMs as well, which are spacecraft. So space and military, you're not going to be able to divorce that if ever you could. You can't pretend that it's not there anymore. It is the cause du jour in DC in defense circles.
Do you think that there is a sort of I can just sort of imagine the lawmakers sort of seeing that increase of investment from the military side, and then sort of seeing that as sort of filling double duty for some of the other projects that may happen on the civilian science side.
Absolutely. Absolutely. If one of these programs is parked in your backyard, you like it even more so because you're more secure with that funding stream, and it's not jerked around as much, and it's big. It's really big. And the mood in Congress is not, hey, let's trust China and Russia to not, screw with our satellites. It's the exact opposite on both sides of the aisle. So it's a money pot, and it's a big one. So
when you look at it from the space exploration side, you've got, we're going to the moon, now we're going to Mars, now we're going to the moon, now we're going to an asteroid belt. The priorities change, but in the world of the military, it's like just learn how to defend the country, how to protect against, secure our communications, know the position of our weaponry. Like, those goals don't really change. And so they've got this vision that they can follow, this long-term plan that they can go without having to sort of move back and forth, right?
It's so right, but it's also as more countries are going into space, the whole question of, is it dual use? Is that laser system on the ground that China is using to track satellites as they go overhead, very peaceful thing. Hey, can you crank that up and actually blind or even damage a U.S. satellite? Well, they could. Yeah. They must be. And then boom, there you go. So
how do you defend against that?
Yeah. Oh, I'm doing a space launch. It's a ballistic launch. It's this. It's that. Oh, it's maneuvering. It's gonna space protection. No, it's a space weapon because it can move. Oh, we put an arm on it. The arm could grapple the satellite and force it down into a lower orbit. All of this stuff is happening at once. So if you want to see the boogaboo, you see it. If you don't want to see the boogaboo, you don't see it. Now, very smart analysts see that China is doing things explicitly that are way too suspicious. So I'm not.
Well, and it's not even that.
But it's there if you want it. That impulse that you're talking about, the pull is there.
Yeah.
And they're willing to push it always, always, always. So.
And even if, say, the United States isn't willing to do it, as you said, China is very willing to do it. Their launch schedule has ramped up and ramped up and ramped up, and the number of rockets, like, we're reporting on just rocket after rocket after rocket that's going off in China, both scientific missions, military missions, commercial missions. It's they're very seriously looking to gain the high ground in space. And then it's up to the United States to decide how they're going to respond. And so you can really see them looking to loft more rockets and satellites as well. All right. Well, we're going to have to... Morgan, when will we know what the final budget's going to be? Next year?
No one really knows. No, we should... If things work, we should know this year. The normal budget process would have the budget bills being passed sort of this summer after being worked on this spring. But I think we all know that Congress doesn't pass the budget quite as effectively as we might like them to. And so really your guess is as good as mine. But the fact that they passed this sort of rough outline of where the budget's going to be in the next 2 years certainly eases the process of filling in all those numbers, because basically everybody's a winner. And so it's much easier to do that than it is to actually have to pick and choose.
So place your bets.
And so hopefully we'll see in the next couple of months where things will be looking.
So place your bets then. Budget comes through, or NASA gets an administrator. Which comes first?
Oh, I think the budget will happen first. NASA seems pretty much stuck in a rut
with having an administrator.
I'm not taking that bet.
Poor Jim Bridenstine is stuck in eternal limbo.
All right, Morgan, you had another story to share this week.
Yeah, some pretty amazing news from ESA, the European Space Agency. They had some researchers this week publish a paper analyzing some of the first results coming from LISA Pathfinder. And the LISA mission is a proposed successor to LIGO, the Gravitational Wave Observatory, that takes it into space. And this is really important because one of the reasons that LIGO has struggled so much is that the signals that you're looking for are really small compared to like normal everyday things. I once heard a LIGO researcher say that if a gravitational wave passed through their sensor at the same time someone like slammed their car door, they'd miss it.
Well, that's why they have two.
Exactly. And so the ways you get around this is by banning people from having cars or getting more sensors and putting them farther apart. Because the farther apart you are, the less likely any signal is to contaminate your sensors. And so the ideal place to do both these things is in space, because you can get basically arbitrarily
super far apart.
And there's only one car in space, and its doors are not opening and closing.
Right.
And so
there's three on the surface of the moon too.
That's the idea behind LISA, the Laser Interferometric Space Antenna. So some satellites that'll basically shine lasers back and forth and measure the acceleration between them. And if a gravitational wave passes over them, they should be able to detect that acceleration and make even more sensitive gravitational wave observations. The thing is that to do this effectively, you have to be like stupidly, absurdly, crazy sensitive. They think that to really work, LISA is going to have to be able to detect accelerations in the neighborhood of 3 femtometers per second squared. And sort of give you a sense of that, a femtometer is a millionth of a nanometer. And like the nucleus of a small atom is like a few femtometers across. Like a whole atom is enormous compared to a femtometer. And so these are just absurd sensitivities that you need to be able to have to detect these gravitational waves passing. And so to prove that this like could even sort of in principle be done, ESA launched a mission back in 2015 called the LISA Pathfinder that basically was to test some of the electronics behind this, to test their ability to like keep the spacecraft steady. And their goal was to measure accelerations down to 20 femtometers per second squared. Remember, the target is about 3 femtometers per second squared. And so after a couple of years of data, they finally published their first results, and they're just stunning. This testbed Pathfinder mission has been able to measure accelerations down to 1.71 femtometers per second squared. So more than 10 times better than they thought that this particular technology could even do, and more than enough to succeed for LISA. And in fact, the biggest source of uncertainty that they have left is the fact that the spacecraft sort of, as it cools down in space and experiences a vacuum, just leaks gas molecules out of like the welds between the pieces of the spacecraft. And those individual molecules and individual atoms of gas were running into their test masses in the vacuum. And like one molecule hitting their test mass would be enough to disrupt the sensor enough to cause noise.
Right.
And
so, like tiny little accelerations. I can just imagine.
Yeah, but like one gas molecule at a time is the level of sensitivity that LISA Pathfinder was able to do. And
how do you baseline a system that's that sensitive? How do you know that something's happening versus not happening if it's that sensitive?
Yeah, that's a great question, and the answer is you have to really beat down your noise and your uncertainty. And the reason that this mission was so much more accurate than they were expecting it to be was that they discovered they could basically average together longer strings of data than they thought they could. So the limiting factor initially was basically how accurately can the spacecraft know its position. It has cameras that look at stars and they measure the positions of those stars and sort of compute their orientation and position. And the idea was to do this, with strings of data to average out. But they thought that eventually more systematic effects would take over and sort of disrupt that process. And what they found is they could actually average together much longer strings of data, which gives you more data points, which gives you more sensitivity, which beats down the noise enough to the point where something is real or not real. And it was well beyond what they sort of even optimistically had expected would be possible for this mission. And so, unsurprisingly, LISA has been approved for construction. And the big question now is, can they find materials that are less gassy, that are able to either release this gas more predictably or release less gas? So remember, we're talking about like individual gas molecules drifting out of these materials. That's the limiting factor now. And so they have some time now before LISA actually sort of goes into construction to think about, are there better materials than what we normally build spacecraft out of that are suitable for this really specialized process?
And that's the heartbreaking part, right? Is that LISA Pathfinder has delivered this amazing success. LIGO has turned up these gravitational waves. We've seen the kilonova. We are ready for the gravitational wave bounty of science, and LISA's not going to launch until the mid-2030s. Like, we're 18 years away from LISA.
Yeah, it's tantalizingly close, but so frustratingly far away. And I think people were expecting that LIGO was going to take longer to really see anything. They were expecting that you need more LIGO stations before you could really
fair
make
to say LIGO took a long time to see anything.
Oh, it did, but we were thinking that it would probably take even longer. And then we were thinking at least a Pathfinder wouldn't be sensitive enough, so we would need maybe another one to generate. And so already sort of penciled in were these steps that were just turned out that we've been able to skip. We're seeing things with LIGO that we thought only Lisa would see. We're sensitive enough with Lisa Pathfinder that we thought only Lisa would be. And so, all of these pieces were put in place predicated on certain assumptions. And it's sort of the best kind of delay in the sense that, oh boy, we're doing more now. So all that other stuff now seems a lot farther away than we originally thought it was going to be.
That's awesome. All right, we're just running out of time. I've got one quick story I just want to mention, and I actually stole this from Kimberly, who was going to be here, and then she was not able to make it. So the European Southern Observatory's Very Large Telescope's Espresso Instrument, and I forget the exact, it's the the Echelle Spectrograph for Rocky Exoplanet and Stable Spectroscopic Observations Instrument. And what it is, it's a super duper planet hunting instrument, spectrograph, that's going to be connected, or is now connected, to the Very Large Telescope Array in Chile. And what's cool about this is you've got these 4 separate telescopes, these 4 8-meter telescopes, and they're an interferometer, so they all work together to combine their light. And for the first time, ESO has been able to combine the light from these 4 telescopes into this one instrument. And it is it's going to be using the radial velocity method to find exoplanets. And so the instrument is going to be able to detect the stellar motion of stars. So if you know how the radial velocity method works, you've got a star and then you've got a planet that's orbiting around it. And as the two are orbiting the barycenter between the star and the planet, you get this sort of jostling back and forth of the star, and that changes the spectrum of the light, and you're able to then sort of reverse calculate the mass of the planet and the orbit that's going around it. HARPS, which is sort of the current best instrument that's attached to the VLA, is able to calculate this speed, this wobble back and forth at 3.5 kilometers per hour, which is amazing, right? You could walk faster than a planet is pulling its parent star around. Espresso is going to be able to take that to 0.35 kilometers per hour. So almost a snail's pace, as ESO is happy to sort of describe.
This is just the sensitivity episode of the Weekly Space Hangout.
It really is. It's a very sensitive episode of the Weekly Space Hangout.
It's perfect for Valentine's Day.
Right, for Valentine's Day. So what you're going to get, and this is sort of the payoff of this, is that now with the Espresso fully connected, attached to this interferometer array, is you're going to have a ground-based telescope that's going to be capable of finding Earth-sized worlds in the habitable zone of red dwarf stars. So we're not quite there at that holy grail, but the kinds of discoveries that Kepler was making at the end of its run, now this is going to be possible from the ground.
So are they planning to point this thing just at random stars and see what they find, or is this mostly going to be following up on Gaia and Kepler and the like?
I don't know what they're planning to study. My guess is it's going to be everything, but I don't know specifically what they're going to be observing.
You guys are the best that I've ever met that could answer this one. If you put that thing on the dark side of the moon, how much better and how much sensitive, how many more exoplanets could we find? I mean, without the atmospheric disturbance, what's the factor of improvement of doing something like that?
Morgan, well, I mean, that's the Hubble space. I mean, that's what the Hubble Space Telescope is all about, right? And that's what Kepler is all about. So when you look at Kepler, it is a relatively small telescope compared to, the VLT. You've got 4 telescopes, 8.5 meters across, using interferometry to pretend to be a 16-meter telescope with a baseline of sort of of how far across these telescopes are. and to match the kind of capability of a space telescope like Kepler. So it's
in some senses, these kind of exoplanet measurements are actually like the holy grail for ground-based telescopes, because using things like adaptive optics, we're able to correct for those atmospheric disturbances really well. The trouble is that we can only correct for them over like a really small region at the very center of the telescope, which was much smaller than the region that Hubble could see out in space. But stars are also really, really small. And big, fancy spectrographs like this are really bulky and really heavy. And so in some sense, like many of our most accurate measurements of radial velocities come from telescopes like Keck, because they're way bigger than anything in space, and have these really advanced, really bulky instruments. And a star and its planets fits really cleanly within that central, really sharp part of a ground-based telescope. What you get from the big space-based ones is those broad, sharp views. But you have all the limits of having to launch things in space. Now, if you could snap your finger and put it on the dark side of the moon, of course, all of that goes away. But Elon hasn't invented finger snapping technology yet. And so it's a trade-off between all of that.
Far side of the moon, not dark side of the moon. So please don't send us your emails. We know.
I say dark side of the moon.
Everybody did. So I just want to head that off in the past. All right. So it's time to get to our second interview for this special, very long episode of the Weekly Space Hangout. So here we go. And we're back from our interview. Time to wrap things up. We're not going to go through our regular shameless self-promotion, but Joe, since you're a special guest, where do people find out more?
You can go to joepappalardo.com or just put in Spaceport Earth if you want to find the book, or check out popularmechanics.com. I read on there, a couple of times a week. These days, even more so with all the news coming out. But you can find me there.
And let's see the book one more time.
Delighted.
Boom.
There it is.
Right on. Morgan, where do people find out more?
Yeah, you can check out my website, morganrenberg.com. I had a great new video drop on SciShow Space just yesterday.
I watched, what's funny? I watch every SciShow Space now, and I go to the end.
You go faster than you watch them faster than I watch them, too.
Yeah, and I'm like, this sounds like Morgan.
So this one is about whether we could give Mars a giant magnetic field, and it's crazy to think that NASA is actually proposing that.
Love it.
Jim Green, the head of the planetary science at NASA, was sort of the one who gave the big presentation on that. So
that's right.
Awesome. All right. Well, hey, thanks Joe for joining us this week. Thanks to all of the folks from the Weekly Space Hangout crew, of course. They are the community who join us every week to share, and they provide the chat that's going on down at the bottom. If you want to be a member of this great community, help pick the guests. Again, Joe came here. I don't know how. I wasn't involved. It just happened. Here he is. I get to interview him. So thanks to the WSH crew for putting that together. So if you want to be a part of that community, go to wshcrew.space, and they will fold you into their community, and you can chat. And I'm looking at the Slack chat right now. All kinds of interesting things going on. So, all right. Let's switch to that view. Here we go. There we go. And everyone can say goodbye.
Bye. Thanks,
Bye,
guys.
everyone.
Bye.
Thanks, guys. All right. I'm going to run the interview now. I think this is the plan. All right. Hold on. Same problem. I haven't solved this yet, so I apologize in advance. Buckle up. This is a long episode. All right. Here we go. I know. I can do something here. All right. I'll start the interview, and I'm going to mess with the size. Here we go. All right. Joining me once again for a second time is Chris Profit, who wrote SpaceX from the ground up And of course, with the launch of the Falcon Heavy, he's back to talk to us about this mission and what this means for SpaceX and what this means for sort of the competitive landscape for other rocket companies as well as NASA. Chris, welcome back to the Weekly Space Hangout.
Hi. Thanks, Fraser. Great to be back.
Now, we covered the launch. Oh, so can you move your camera now just like down a little bit here? I can. There. Yeah. Okay. That's perfect. That's perfect.
Okay.
Yeah. So we covered the launch of the Falcon Heavy here on the Weekly Space Hangout. Obviously, we were all incredibly excited. It was a tremendous accomplishment, and sort of a game changer to see a car go into space. What an amazing accomplishment. Of course, this is just the harbinger of a whole new future. So what do you think the impact of the Falcon Heavy's launch is going to have on the space industry as a whole?
Well, it's an opener basically. The super heavy lift rocket, it can basically lift any payload they can envisage at the moment. So it's also opening a door to some payloads we haven't even thought about. Who knows, maybe they could put a Europa Clipper out there. I believe it was included in NASA's plan on the budget. That's good. Maybe even put a lot there. Who knows? It's super heavy lift. If they go disposable, that's 64 tons to low Earth orbit. That's a lot of.
All right. So you kind of threw a bunch of things in there. The the Europa Clipper currently is planned to launch on an SLS, right, in the sort of early 2020s. At this,
I'm going to have to disagree on that one. I just had a look at the budget for NASA, and they say they prefer a commercial launch vehicle because, well, it's going to be because of budget constraints. So at the moment, it seems to be going Falcon's way, or maybe some other commercial. But
we're in a day of flux, though, right? Because the White House released their new budget just in the last couple of days, and it sent the entire space industry sort of reeling to try and figure out what the consequences of this are going to be. So I think anything that we say right now, there's a lot of studies and such that are going to be coming in the next couple of in the next few weeks and months to sort of swap everything around. But so you can kind of see that, and also sort of what do you think is happening with the other launch companies out there? United Launch Alliance, what's happening with the Europeans with Arianespace? I mean, you're seeing this at $90 million for the reusable option, what, 150 for an expendable?
Expendable 150, expendable. I believe it's 95 million if you expend the center core. So it's only a little bit more. I mean, I think the French said we've been expecting the SpaceX steamroller to arrive for some time, and basically it has.
Yeah.
I mean, the Falcon 9 reusability was sort of quite tough enough competition, but now they got the Falcon Heavy. Well, Elon Musk was quite ebullient about it. He was just saying, well, there's nothing they can't do now. They had some gaps in their inventory. They couldn't do some certain reference orbits like heavy launch to GTO and direct injection to GEO, which is mainly sort of military and big comsats. But now, of course, it's wide open. There's no gaps in
right. So
in their
can we just go back
whatsoever.
for a second there? So like the capability of the Falcon 9 is that it could do certain classes of launches, but there was a group of them that it couldn't do, and this sort of meant that SpaceX couldn't bring on board certain Air Force and various military payloads because it just wasn't capable of doing these things. And so one of the objectives with the Tesla launch was to demonstrate. I mean, can you talk a bit about that special orbit that the Tesla went on, and sort of, it was a bit of a show off above and beyond just putting a car in space?
Well, yeah, absolutely. I mean, from the sort of military point of view, it had that long loiter time. I think it was like 6 hours in the Van Allen belt, which you have to do if you want to do that direct injection to Geo, I understand. So it's basically saying we're out here and nobody can touch us. If you want to go, if we want to go to Mars or even the exceed of the Mars orbit, we can do it. So yes, they were selling to the military, but they're also saying, look, you know, the solar system's now wide open. Any sort of planetary mission you want to do, here's the launch vehicle, and you don't have to do flybys to improve your speed. You can just go direct with the Falcon Heavy
Right.
now. But it's a great it's a great vehicle, really. Ah, yes, nice to have friends.
Chuck, come here. Come on, Chuck. Come here. Come on. You don't need to bark. My wife just left the house, and so the dog is like freaking out. I am not acceptable. Please please continue. So right. So how many launchers out there right now can pull off? I mean, I know that the Falcon Heavy is the sort of most powerful rocket that's currently capable, the most powerful commercial rocket ever made. What other launches out there are in the same class as the Falcon Heavy right now?
Well, it's really Ariane, isn't it? Ariane 5. They can do what similar sort of payload to GTO, but I mean they have a slight advantage because they have a higher energy upper stage, as I understand it, whereas Falcon's just a big Kerolux chugger. It's powerful, but it's not so efficient. But it's great for putting stuff up into LEO, and of course you can go beyond if you want to expend cores. You can go even faster. It's going to be really useful. But it's a rocket of its time, really. They needed to do some Falcon Heavy now, because in the past we've had GTO missions where they've just expended the core because the payload's been too heavy. That's okay with the Falcon 9s previously, but now next month they're moving to Block 5, which is fully optimized for reuse, and they schedule it to have 10 flights. Then they'll do a refurbishment, and then they'll do another 10 flights. So if you're gonna have these expensive rockets, you don't want to be throwing them away. But of course, Falcon Heavy stands in. It'll do all those heavy flights, and even as you say, the high reference ones to direct injection to geo, planetary ones. It's got all the angles covered basically now. It's a good, useful launch vehicle. And of course, when Falcon Heavy becomes Block 5, then you only need one, and a whole bunch of upper stages, of course.
So how many launches are currently sort of queued up for Falcon Heavy right now?
Well, I understand there's 3. There's Arabsat 6A, there's SDP2, and I believe there's a Viasat 1 a bit later on. So that's what they've got at the moment. But it's a strategic move by SpaceX, because they're saying, well, look, we have this capability, and then people can come to them. And some of these planetary missions have got a long lead time. So by the time they turn up, well, we've got BFR. So they're using it as a feeder for the BFR, because they're definitely going to need payloads for that, big ones too. But I think talking about the possible payloads, there's a bit of a mystery going on at the moment. But did you hear they're building a new ASDS, automotive, or a drone ship? No?
I had heard that they're going to build that new drone ship. Yeah.
Yeah. What's it called? Shortfall of Gravitas. Yeah, it's going to be on the East Coast. So they're going to have 2 there. They say they're going to use it for booster landings, so the Falcon Heavy. Presumably they're going to expend the center core, and they're really, pushing that launch. But there's no launch. There's no payload for it at the moment. So that seems to be a bit of a mystery. I know payloads sort of turn up at a short notice, like Zuma. It's just a month before, we're launching, right? But I'd like to find out more about that. That's really interesting. What possibly could they launch would need that sort of thrust
So can you talk a little bit about the sort of the state of human rating with these rockets? Like, where is the Falcon 9 in its level of human rating? Why did they decide not to human rate the Falcon Heavy? And what are sort of the plans for that with the BFR and sort of what its implications are for NASA?
Yeah, well, not human rated. I mean, when SpaceX say things, they say this is the direction we're tending to go, but plans do change. They change all the time at SpaceX. Elon Musk gave a caveat when he said we're not planning on going on the moon anymore with Falcon Heavy. He says that's assuming that we don't have any problems with BFR. Right, so I mean, saying the most innovative rocket, this millennium, there won't have any problems in it. I mean, only Elon is so optimistic. So it could well be on the cards, but it's not
right. I mean, I think that's the thing, and it's funny. So, I just posted a video about sort of the state of the SLS and sort of the the rockets, the engines, the RS-25 engines on the SLS, and they're magnificent, sort of Ferrari of rocket engines. They're wonderful engines, and people were just kind of like, oh, why is NASA even doing this? What's the point? Blah blah blah, right? And like SpaceX only demonstrated reusability of its rockets within the last year. That the Falcon Heavy just launched a week ago. That to then and how many years late? 4 years, 5 years late from its initial schedule. It's like what does NASA do? Does NASA just lay off their entire workforce for SLS and then wait for SpaceX to meet whatever deadline it can, and then here we are 10 years down the road. Turns out the BFR was harder than we thought. Sorry, NASA, you don't have any capability to launch humans into space. Not a problem, right? So I think that I mean, obviously, I think you're exactly right, that if we can the timelines have always been aspirational, and to expect anything else is kind of missing, not understanding the way these timelines seem to unfold. And at the same time, now that the Falcon Heavy is flying, now that it clearly works, the orders are going to start racking up, and NASA is always the biggest customer of SpaceX. So, they'll buy Falcon Heavies too.
Yeah, and save a lot of money. I like what Elon says about it. When they buy a SpaceX launch, it's so much cheaper to launch with them. They essentially get a satellite for free because they're saving that much money.
Yeah, well, so, that there are mission planners in NASA right now who are saying, we could launch this on a Delta Heavy or on an Ariane 5 for 400 million or 300 million or whatever the price is going to be, or we could just get 2 satellites and launch them on Falcon Heavies. Or
get a bulk deal,
or yeah, exactly, get a bulk deal, or knock half the flight time off of our mission to the outer planets, because you can do a much more direct launch. So I'm sure it's incredibly exciting. I'm sure a lot of people are just updating their spreadsheets with brand new launch cost numbers.
Well, I'm sure they are, but from a SpaceX point of view, they're entering a new era. I mean, before they were just a launch company pushing stuff to orbit, essentially, but now they've evolved into a transport company, which is basically we can send anything anywhere in the solar system. That's always been their next evolution, and one of the first places they want to go is Mars, of course. Although recently there seems to be a bit of a pivot to the moon because of the administration. They like the moon, so why not? You bend with the wind, you don't break with it.
And the moon actually seems like a much nicer demonstration of the capabilities of the BFR, that it just flies up, lands on the moon, people hop out, dance around on the moon, they get back on the spaceship, and it flies back to Earth and lands. It's a very straightforward mission, right? Compared to the shenanigans that are going to happen to actually get down to the surface of Mars and bring humans back to Earth, as well as the timelines involved. For me, it seems like really the no-brainer.
Yeah, it's like Play-Doh, as you say. It's just a matter of propulsion. I mean, they won't get so much any braking at all from atmosphere, because the moon has no atmosphere, but they just take more fuel, do more propulsive retro propulsion, and they're there. And the idea is it's so large, you don't have to get back on it. You can set up a colony. That one rocket, they've got it. You want a delivery every week, you get a delivery every week.
So how do things play out then? I mean, here we are. Falcon Heavy has just completed its mission. It's sent Starman somewhere out there. What happens next? How do you think we're going to see things play out, and when do we expect, hopefully, the BFR will come online?
Oh, well, we've got a pretty good idea. We're going to be seeing BFR, the upper section, next year. That's what we've been told. Elon is happy that it's going underway. It's doing great guns, and they're setting up Boca Chica Beach to be the test site, but they're just going to do some hops. Did you see the Grasshopper program? Similar to that, but with the BFS, the Big Falcon spaceship. Right?
So just to be clear then, like the BFR is those two components. You've got the top part of the spaceship, and then the bottom part, you've got the booster section. That first
the
stage,
BFB,
which is kind of like the equivalent of the first stage of the Falcon rocket. So we're going to see that top part take off, fly to some altitude, and then return to the landing site.
Yeah, hopping around. That's the hope. Yes, it's gonna be mighty. They say they've got a load of empty space down there. Not many people living in the area, so it's pretty well ideal. This is in Texas.
Yeah.
I mean, the only other option they had was to fly it from one ASDS to another. So. Which does kind of make sense that they're building two, but they're building it a year too early because they haven't seen the upper stage yet.
So have they got? So you're saying like hop from one site to something downrange and then land in another facility, but they don't have that second facility up and running yet. I mean, they could go to Florida. They could go from Texas to Florida, but.
Well, eventually they can go to orbit because it's a single stage to orbit. It's such a high performance that the weight is really low.
The BFS will be able to do single stage to orbit all on its own without the booster?
That's what we've been told. Wow. Low payload, because it's the carbon fiber. It's so undense, right? Light. And those Raptor engines, much higher ISP. Yeah. So it's just a question of just taking you and the dog or whatever, something. Right.
Yeah, I mean the whole concept of single stage to orbits have been tried and thought about for a long time, and of course NASA had the Venture Star and that, in the X-37, and that ended up not coming together. But even so, theoretically, even the best possible performing single stage to orbit is not going to get you a lot of payload into space. It's when you get that staged rocketry, and that's sort of the magic of the BFR is that you've got those stages. You got that bottom stage, you got that top stage, and so you've got staged rocketry, and yet both are reusable. That's when the whole thing's going to come together, and you're going to get the best of both worlds.
It's cream and cherry, yeah.
Yeah. Yeah, but that's amazing. Next year we could see, sometime in 2019, we could see the BFS hopping around like the Grasshopper at a gargantuan scale. That's what Elon says. We've got to have faith in our Elon. Yeah. Well, maybe Chris, then that'll be the time to come back and talk to us again when that next sort of accomplishment has happened. That just sounds amazing. So, Chris, tell people again sort of your book. I'm assuming it's time to write another update.
Oh, well, no, actually, the fourth edition was pretty I like to view into the future, and I had a section about Falcon Heavy, and it's all factored in there. So,
did you know what the payload was going to be when you did the?
No, I didn't. But I try to sort of look at things on a larger view and just say, well, look, it's going to be available, and it doesn't actually affect the finances. For a while, but I mean, at the end of this year, probably after they do the IAC, because I heard rumors they're going to do another presentation, like an update, this year's IAC. So maybe there'll be time to sort of run another one when we've got a better idea what their launch
That's
profile is.
the International Astronautical Congress. That was the one that was held down in Australia last year.
Adelaide, and then the last one was in Mexico. Yeah, that's right.
Right.
30 launches this year. That's phenomenal.
Yeah.
But again, that's aspirational. But they did 18 last year. And the crazy thing about it was they had 10 billion on launch manifests. So they had $10 billion worth of things to launch. And at the end of that year, they've done 18 launches, which is just phenomenal. And their manifest has gone up to 12 billion.
Yeah.
So they're not. they need those. They need to keep just pushing that up another 50% just to keep track of it, basically.
Yeah. It's such a surreal time. I gotta say, like I never felt like space exploration reality was really happening, and then seeing the Falcon Heavy go up, seeing those Falcon rockets, those twin engines come back down and land at the landing pad with this beautiful dance. You just say, okay, finally, you know, we took a break and now it's time to go back.
Yeah, our animations don't lie to us. It was exactly like the animation.
It really was. I saw a great comparison. Yeah. Someone had compared the animation, that original animation that that SpaceX had built with the reality, and it was like you could barely tell which side was which I thought was wonderful. Yeah. All right, Chris, thank you again for joining us here on the Weekly Space Hangout. Again, your book, SpaceX from the Ground Up, available in all places where books are sold. Check it out.
Mainly Amazon.
Mainly Amazon, but definitely check it out. And where can people follow you out there on the internets?
Oh, well, if people want to get in touch, you'll find me over at SpaceX Reddit quite often. I'm on Google+. So, get in contact with Reddit. I mean, I'd love to have a chat with
you're definitely very
anyone.
active. I mean, a lot of your material came together with that community, which I think is an awesome way to sort of build a book. So, all right, great.
I found them, and they found me.
Yeah, exactly. All right, Chris. Well, keep us posted when the BFS is flying. Please come back and let us know how that's working out.
Okay.
All right.
Yeah. Looking forward to it. Great day. Thank you. Thank you, Razor.